All right, section 7.2, multiplying polynomial expressions and functions. We're going to learn the meaning of binomial and trinomial, and we're going to multiply polynomials, and we're going to find the product of functions, and we're going to use the product of functions in real-world problems. We'll probably leave that to Lehman to do in his book. Now, example number 1, we're going to be just labeling these as monomials, binomials, trinomials, or as simply, that should say simply a polynomial, not a trinomial. So let me change that really quickly as a polynomial. And remember, any of these can be termed as polynomials. Now, monomial, the prefix mono meaning one, so it's a one-term polynomial. A binomial, meaning prefix meaning bi, meaning it has two terms. And trinomial, again, prefix tri meaning three. And anything above that we call just simply a polynomial. So our first example here, I'm going to use some abbreviations: M for monomial, B for binomial, T for trinomial, and P for polynomial. So our example A, it has two terms. Notice that the plus here separating the one and two terms. And so this is a binomial. And remember also that any binomial could also be simply called a polynomial. The next one, we see only one single term. This is a monomial. Again, remember, any of these could be also called polynomials. Now the next one, I see an addition sign here and a subtraction sign here, which separates my 1, 2, 3 terms. So 3 terms, that's a trinomial. And again, remember, any of them could be called polynomials. Now the next one, I have one subtraction, another addition, and another subtraction, separating my 1, 2, 3, 4 termed. A 4-term polynomial we have no special name for, and so we can only call this one a polynomial. All right, now moving along, let's review our distributive property, let's review our monomial times monomial, which we actually did in section 7.4 when I covered that. So remember, what we did is we simply said, okay, we're going to use the associative and commutative properties of multiplication to multiply these. So we said 5 times -6, which gave us a -30. And then we said we're going to associate and commute the a squared and the a to the first. And when we multiply like bases, we add their exponents, so that gave us a cubed. And then the b squared, there's nothing to associate with it, so we'll just write it down. And that was our monomial times a monomial. Now the next one here, same thing. We have a -1 here, right? -1 times a +3 is a -3. And associating the r's, r squared times r to the first, and we're going to copy the base and add the exponents, so r to the 3rd power. And then the s's, again, commute and associate the s's, so the s to the 2 plus 1 power, so s to the 3rd power as well. And so that was a monomial times a monomial, something that we just covered as part of our exponent rules. All right, now moving on to review our distributive property. Remember that when we had something multiplied by a sum, that the multiplication distributes over the addition, giving us a times b plus a times c. And even when a, b, and c just aren't numbers or variables or a number times a variable, this still applies. So we're going to look at this and see that we have 1, 2, 3 instances of a monomial times a monomial. So I'm going to write this one and only time completely out so that you see that this is nothing more than an application of the distributive property and then multiplying monomials. Now, I do not expect you to actually write this out. I just want to be very thorough in showing you that we're just applying that monomial multiplication. So we have 2x times x squared, which gives us 2x to the 1 plus 2, which is 3. And then plus 2 times 2, which is 4x times x, which is x squared, plus 2 times 3, which is 6 times x. Now again, if you have been in an algebra class before, you might be tempted to say, oh, I need to factor that. Remember, factoring comes after we learn to multiply out, and it just takes a sum and takes it back to a product, so we're not doing that. All right, in the next video, I'm going to be doing some more